To solve another Leetcode problem. 1524, number of subarrays with odd sum. Let's first try to understand. Given an array of integer array, return the number of subarrays with an odd sum. So as the numbers can be really large, so we're gonna return a modular 10 to the power of 9 plus 7. So basically we need to prepare a mod. It's gonna be 10 to the power of 9 plus 7. Yeah, so this is just according to the description. And how to solve the problem? As we are going to check the sum up of all the contiguous subarrays, because subarray must be contiguous. And for this example, as we can see, the answer is going to be 4, and we find all the subarrays and the sum up of all the values, and then we just check if it is odd. So if it is odd, the answer is going to be 4. And also for this example, the answer is going to be 0 because they are all even numbers. Yeah. So for solving this problem, basically we're going to try to find some solutions, because as we can see, all the arrays is contiguous. So this may be because we are calculating the sum up of all the values. Maybe we're going to consider if we can use a prefix sum to solve the problem. The prefix sum idea is that first of all, we're going to check all those numbers array. If we have an array, so for example 1, 3, 5, we're going to check the prefix sum. So the prefix sum of the array is going to be 1, 4, and 9. So while we are checking this array, we don't need to count the prefix sum between a subarray. So for example, what is this value, like what is it calculated inside of the sum array, because that's gonna take the time. Yeah, because basically we need to use O(n) time or n log n time to solve the problem. We cannot use brute force. So this means we cannot sum up the values. We don't need to check the values. We just need to count if the prefix sum is even or odd. So the idea is that we're going to prepare a prefix array, and then this prefix array is just the prefix sum of the array. Now, we want to prepare a prefix odd count and prefix even count, and this is helpful to solve the problem. So we're going to prepare a p odd. So this means while I'm checking the current prefix number, this one, so how many values of the prefix odd, and also I need to check the prefix even number. Yeah, so this is helpful for me to solve the problem. So while I'm checking this number, so for example, this is an array. While I'm checking this number, I want to check the prefix count of the odd and prefix count of the even. So currently, if this prefix number, so if this is odd, so what I'm caring about is for the prefix sum numbers. So how many even numbers? Because if it is odd, this odd minus the odd, the subarray must be even. So I want to check the prefix even, how many count. Maybe it is 5. Let's just try to use an example. Maybe let's just use 3 maybe. So this is the prefix 1. So for this one, it is even. And up to here, this is another one, it is even. And up to here, this is even. So we have 3 count of even before our current number, and this current number is odd. And for this current number odd, we should know that how many subarrays do we have, because this odd number minus an even, it must be odd number. So it means from here, this is one subarray, this is another one, and this is the last one. It means we have 3. But we should also include itself, because this number is odd. This prefix sum is odd. This means from here to here, this is also odd. So it means 3 plus 1 is going to be 4. Yeah, but reversely, if this dot is just even numbers, so this means we want to check how many odd subarrays. So maybe this is O, this is another one, maybe we have two odd. Yeah. So as this is even, we will not count this one, because it is even itself. We will not count this one, but definitely we will count the subarrays from here, because this one, even minus odd, it is odd, and we're also gonna count this one. This is also odd. Yeah, so if we understand the problem like this, basically, now we can use the prefix sum to solve the problem. So I'm gonna prepare a pre-odd and pre-even. So from the beginning, I'm gonna count it as 0 because currently I didn't check any numbers. Now I'm gonna prepare a prefix array. It's gonna be list accumulate with the array. Now I want to check each of the numbers for the prefix array. So for n inside of the prefix array, I want to check this number. If this number is if this number is odd, so basically this means I want to get my result. Let me just prepare a result to be 0. So it's going to be result plus equal to how many prefix of even numbers, because this is odd. Yeah. But it can plus itself because this number, this prefix is odd. Itself is also odd, so I need to plus a 1. Else, if n modulo 2 equal to 0, it means this is even. So the result would plus equal to the prefix odd. Yeah, we don't need to plus 1 because currently this number, this prefix sum for this number n, it is even, so we don't need to plus it. Yeah, but we need to check the previous prefix odd or previous prefix even numbers. Yeah, so after calculating this one, we need to record the result. So this is odd, so we need to record the odd plus 1. And similarly, this is even, so we need to record the even, it should plus equal to 1. So finally, we're going to return the result. As you can see, this is a prefix sum problem. And this is also difficult to think about it. Yeah, as you can see, this is just an ON solution. The time complexity is going to be ON. But the idea is that while we are checking the current number, while we are enumerate the current number, we're going to check the previous even and odd count to get the solution. I think it's going to be wrong because I forgot to modular the mod. Yeah, as you can see, it's going to be a big number. Now let me just submit it to check if it works after adding the mod. As you can see, it works and it's pretty fast. Thank you for watching. See you next time.